Hello grade 11s, once again we meet for this interesting subject which is mathematics. Today we're just looking at the exam preparation for your paper 2, and for paper 2 in term 1 and 2 you're looking at analytical geometry and trigonometry and a little bit of Euclidean geometry. Okay, so those are the two that we're going to be looking at today. Just a reminder, guys, when you have your analytical geometry, you have to understand all your formulas and where are they supposed to be used. For instance, let's just do a recap. If they're asking you for your gradient of a line, your m is change in y over change in x, right, which is your y2 minus y1 over x2 minus x1. So it means you'll be having two sets of coordinates, and then you call one set 1 and the next one is set 2, and then your first x or x1 and y1, and then your x2 and y2. Now they can ask you to find the equation of a line, and the equation of a straight line is given by y equals to mx plus c. Okay, all right. So and then from there, they can also ask you to use the other equation of finding the line, which is your y minus y1 equals to m into x minus x1. Okay, right? So in the line, they can also ask you of the midpoint. They can ask you of a distance. So if they're asking you of a distance between 2 points, for instance, you've got your A and B, all right? So they're asking you to find the distance AB, right? So your formula for the distance, so you'll be saying your AB is given by the square root of your x at B minus your x at A squared plus your y at B minus your y at A. So in other words, you'll be having the set of coordinates there on your point A and your point B, and then from there you can be able to find your distance in units. Okay, and then just to recap again, there can be a point in the middle, then we call that a midpoint. Okay, so let's say this is maybe K. How do you work out the coordinates of K given the coordinates of A and also B? So it means that for the midpoint will be given by x1 plus x2 all over 2 is to y1 plus y2 all over 2. Now, in other words, that's going to be your x at A plus x at B all over 2 is to y at A plus y at B. Okay, and then from there, they've got your midpoint, your distance, and then your equation of a line, and then the gradient, and then they can talk about the lines. Okay, so you've got two sets in your grade 10 and your grade 11, right? If they're talking about parallel lines, okay, so for parallel lines, right, the gradient of the first line should be equals to the gradient of the second line. So your parallel lines, right, you need to be reminded that the gradient of the first line should be the same as the gradient of the second line. And then your perpendicular lines, the gradient of the first line times the gradient of the second line equals to -1, all right? And then they will also ask you about the angle of inclination, all right? And please be reminded to work out your angle of inclination. Your m equals to tan theta, and your m stands for the gradient. And the rest we'll be talking about it when we are looking at the questions concerning your analytical geometry. But just in short, make sure that the formulas, you know all of them, when to apply them. Analytical geometry is the easy section. Let's look at how they ask questions in your analytical geometry. All right. Question 1. The point A, minus 2, 4, B1 and minus 1, and 3, 1 are given. All right. Now, determine the gradient of AB. Right? I am going to give you just 1 minute because of time, guys, to just work out the gradient of line AB. Okay. First of all, you need to identify, okay, these are the points that we're talking about. Okay, this is the gradient of that line AB. So you've got 1 minute to work out the gradient of AB. Quickly, let's work with your friend. 1 minute. All right, grade 11s, let's just quickly look at this. What are they asking for? It's the gradient. Now, remember what I said? You go, you check your formula when I'm given a gradient. So the gradient is a change in y over change in x, okay? So gradient is change in y over change in x, so y2 minus y1 over x2 minus x1. What did we say? For the y1 and the x2 and so forth, you select which one you're going to call it set 1, all right? So whichever one, I can say this is set 1, okay? That should be set 2. If that is set 1, so it means that this is my x1 and then y1, and then this will be your x2 and then y2, all right? So the gradient will be y2 minus y1, so it's minus 1 minus 4, divided by 1 minus minus 2, which is a plus 2, which gives us a minus 5 over 3. So the gradient of line AB is negative 5 divided by 3. Okay, right, now let's move on. Still on the same question, all right? So let's just do this. My line is not that straight. Okay, so the gradient here is minus 5 over 3. Now they're saying by determining the gradient of BC, determine with an explanation whether or not angle ABC is 90 degrees. Okay, right, let's just finish this triangle. Right, we need to work out this side, okay, the gradient, and then we have to decide whether this angle here is a 90 degrees. Let's just look at the different color, okay. We need to check whether that one is 90 degrees. So guys, what must happen there, right? So in order for us to have 90 degrees, it will mean that this line is perpendicular to that line. When does that happen? If the gradient of this line multiplied by the gradient of that line equals to minus 1. So in other words, the gradient of AB multiplied by gradient of BC should be giving us minus 1. So in other words, if I have gradient AB times gradient of BC equals to minus 1, then we'll conclude that angle B there is 90 degrees, okay. Right, now let's check if that's the case. We have, okay, the gradient of BC is given by change in y over change in x, y2 minus y1. So it's 1 minus minus 1. That's a plus 1 divided by 3 minus 1. And what do we get? It's 2 divided by 2, which is a 1. Now, obviously, if we look here, gradient of the first line is minus 5 over 3. Gradient of the second line is 1. What do we get if you multiply the two? You get minus 5 over 3 times 1. We do not get a negative 1, so it means that angle B is some other degree, okay, not 90 degrees. So how do we conclude that? So you say, therefore, it is not A, B, C is not equals to 90 degrees, okay? So that is your statement. Okay, that's the first part. Now, why are you saying ABC is not 90 degrees? Because gradient of BC times gradient of that other line, which is your AB, is not equals to minus 1. Instead, we're getting what? Negative 5 over 3. Okay. Now, still on the same question, right? Let's indicate the things that we have so far. We have the gradient of this one is minus 5 over 3. And then the gradient of that line said it's 1. Okay, so the rest we have not yet found. They're now asking us to find the equation of BC, right? So the gradient is 1 there. We need to work out what is the equation of line BC. Now, bearing in mind that the equation of a line is given by y equals to mx plus c. So in other words, you're going to have the gradient and the y cut, all right? So you have y minus y1 equals to m into x minus x1, right? Let's indicate what we have. For BC, we've got the gradient is 1, okay? Now, we need to find the y cut. You can use any point on the line. Remember, guys, for a straight line, the equation of a line has to be the same throughout. So here, I can use the 1 and minus 1 or 3 and 1 to find the equation of a line. So it means here, I'm going to have the x1, and then here, it's the y1. Okay. Now, you've got your y minus 1. Its m is 1 bracket x minus 3. Right. Now, at the end of the day, what must you do, guys? You make sure that y is the subject of the formula. So you have your y, it's equals to x minus 3. Take the 1 across, you get plus 1. So therefore, the equation of a line is y equals to x minus 2. So this line, it continues all the way, and then it's going to have a y cut at minus 2. All right. So you've got y equals to x minus 2. All right. Now, then the last, this question says, the equation of a perpendicular bisector of BC is y equals to minus x plus 2. Determine, showing you're working whether or not point A lies on this line. Okay, so this is BC. All right, the perpendicular bisector is the one that's going to divide BC into 2 equal halves. So that line will be coming like this, cutting in the middle, okay, right at the midpoint. Or the other option, it can be maybe slightly before that, but depending on the scale and so forth, or above. Now, what are we trying to do here? The equation of a perpendicular bisector of BC is y equals to minus x plus 2. Determine showing you're working whether or not point A lies on this line. All right, so point A is minus 2, 4. Now, if it does lie on that line, your left-hand side should be the same as the right-hand side. So you've got your x value, minus 2, and your y value is 4. So you have y is minus x plus 2, right? You take your left-hand side, which is y, and y is 4 in that case, and then your right-hand side is minus x is minus 2 plus 2, which is 2 plus 2, and that gives us 4. Now watch, guys. Left-hand side is 4, and then right-hand side is 4. So it means that point is exactly on the line. So you conclude by saying, therefore, point A lies on y equals to minus x plus 2. The left-hand side is the same as your right-hand side. Okay, guys, I want you to look at this, and I'm going to give you a break, and then after the break, you'll be able to tell us what you've got. Determine the angle of inclination of CO, where O is the origin, okay? Right, so O is here, so it means that you've got CO there. You need to work out what the angle of inclination is, okay? So I'm giving you this one, you look at it over the break, and then after the break, we look at this question and then we move on. Let's go for break. All right, guys, welcome back. Let's see if we've got it correct. You've got your OC here. You need to work out the angle of inclination. All right. Now, how do you work out your angle inclination? Your M equals to tan theta. All right. So M is tan theta, but your M is the gradient. Okay. Now, what's the gradient of this line? It's a change in y over change in x. So we've got 1 minus 0 over x, which is 3 minus 0. Then your gradient is a third. Okay? So tan theta. Now, how do you work out your theta? Then you'll have your theta equals to second function, 1 over 3. And then your angle here, which is your angle of inclination, is you're going to get it from saying now shift tan of a third is 18.43. So we get theta is roughly 18.43 degrees. Okay, right? Let's hope you all got that. Now, continuing with our preparation of paper 2, we're just going to recap a bit on our trigonometry. Okay? Right. Now, with your trig, remember, guys, that we have spoken about SOHCAHTOA, that your sine theta is opposite over hypotenuse, so that's y over r, and then your cos theta is your adjacent over hypotenuse, that's x over r, and then your tan theta, it's y over x. Okay? And then we've spoken about the quotient identity. Okay? That your tan theta, it's equals to sine theta over cos theta. And then we did our squared identities. And your sine squared theta plus cos squared theta is 1. And your sine squared theta is 1 minus cos squared theta. And your cos squared theta is 1 minus sine squared theta. All right. Now, we're just looking at the things that we're going to need when answering the trig questions. And we didn't stop there. We've spoken about the cast diagram, right? Now we said cast diagram, all students take coffee. It is cold. You need to grab some coffee. All right. Now what does that mean? All the trig ratios are positive in the first quadrant. Second quadrant, it's sine and its reciprocal. And then third quadrant, it's tan. And then fourth quadrant, cos and its reciprocal. And then we said here, we have your 0, 360, 90 degrees, 180 degrees, and then 270 degrees. Okay? And then in the first quadrant, from 0 up to your 90 degrees. Okay, 0, 1, 2, 3, stop at 90. So 0 plus, and then 90 degrees minus. And then in the second quadrant, at 90 plus, 180 minus, 180 plus, and then your 270 degrees minus, 270 plus, and then your 360 minus. Okay? And we've spoken about the positive and negative angles, right? Plus theta, and then you've got your minus theta as well here. Right. And then we're going to look at the rest again. I think this is sufficient. Okay. Now, consider the sketch below. You have your minus 5 to your x and y, and then you need to determine tan theta without the use of a calculator. Now, it goes back to our note again. Your tan is y over x. So tan is a change in y over x. So that is your tan is opposite over adjacent. So tan theta is your y over x, and y in this case, it is positive second quadrant, and then x is negative. So it's negative 2/5. Okay. Right. Now next, determine sine theta in set form without using a calculator. All right. Now, what do we know about sine? We know that sine theta is y over r. Now, we are stuck here. We have x, we have y. So what does that mean to us? We need to complete a triangle, right? So a triangle, we've got 5 units this side. So we have -5 and then 2 there. Then we need to work out what our r is. So now if you've got your right angle triangle, you'll be able to work out what r is using Pythagoras. And we all know that your x squared plus y squared is r squared. We've got the value of x, which is -5 squared, plus y is 2 squared, equals to r squared. And then 25 plus 4 is r squared. Then r is plus or minus 29. So r is square root of 29 units. The distance cannot be negative. So in other words, we have all the relevant information. Our y in this case is 2, and then your r is the square root of 29. Or someone can rationalize the denominator and multiply by root 29 over root 29, which gives us 2 root 29 all over 29. Okay. Right. Now next, it doesn't want to go to the next question. Why? All right. So you've got it. Determine theta correct to 1 decimal place. Okay. So you see, theta is all the way. All right. So we're expecting theta to be more than 90 degrees. You see, it's in the second quadrant. Right now, let's look. You can use any trig ratio that you've worked on. you've done the tan, that is minus 5, that's 2 over negative 5, and then your sine theta was 2 over square root 29. Okay, so now to work out your key angle, right, or your reference angle is, remember, we're saying shift that second function sine of 2 divided by square root 29. That's 21.80. Okay, 21.80 degrees. Okay. All right, so we're still working out the key angle, but in the second quadrant, we're saying 180 minus. So in other words, your theta will be 180 degrees minus 21.8, which gives us minus 180. It's going to be negative, but don't worry. It's 158.2. So you've got 158.2 degrees. So your theta is given by 158.2 degrees in this case. All right. Now, moving on, still on your trigonometry. All right. They love these questions so much, guys. You're given that cos 20 is P. Determine in terms of P, cos 340, sine 110, sine 20, and tan 20 degrees. All right. Now, whatever question you have to relate it to the 20 there so that you'll be able to find a P. Now, in most cases, you'll be given that, say, for instance, cos 45 is K. Always, before you answer this question, make sure that you've got a denominator which is 1. Why? Because you've got your cos. Cos is x over r, right? So that will help you to find the other part, which is your y. So I'm going to give you 2 minutes, guys, to just look at all these questions. I suggest you just write them down quickly, and then you do it with a friend, and then I'm going to respond to you and see if you're doing the correct thing. Right, let's take 2 minutes. All right, grade 11s, we said the first thing that we need to do, if your cos 20 is P, you give a denominator of 1. Okay, so you have your rough sketch here. There's 20 degrees. And then cos is x over r. So you've got your p and then your r is 1. It's now easy to work out what y is. From Pythagoras, you've got your x squared plus y squared equals to r squared. So y is 1 minus p squared. I hope we all got the same thing. Now, and then we said, when now answering the questions, we try by all means to get it to 20 somehow. All right. Now let's see if we've got some space. Yeah. So you've got that diagram that you have 20 degrees. There's 1. There's p square root of 1 minus p squared. Cos 20. How do you break it down? That's going to be cos of 360 minus 20 degrees. Now 360 minus is the fourth quadrant. How is cos in the fourth quadrant? Cos is positive, all right? So you get positive cos 20 degrees, right? Now, cos 20 is a given information. That is your P. So you've answered the first question, right? Now, we move on to the next one. You've got sine 110. Now, how do I get it to have a 20, all right? Now, bearing in mind, what am I using? The 0, 360, 90, 180, and 270. Now, if you look here, you've got your sine of 90 degrees plus 20. You see the 90 plus 20, it gives us 110. So it means we do have a 20 there. Now, 90 plus is the second quadrant. How is sine in the second quadrant? It's positive. But because of 90, sine changes to cos. So you've got your cos 20 degrees. But what is cos? Cos is given that it is P. Right. Now, sine 20. Now, this is where the tricky part comes in. Let's go back to our diagram. This is 20 degrees. That's P, and then 1, and then the square root of 1 minus P squared. Right? Now, sine 20 is y over r, so it's going to be the square root of 1 minus P squared over 1, which gives us the square root of 1 minus p squared. Then next, your tan 20, we still have that diagram. Oh my goodness, we keep on drawing this diagram. That's the p, that's 1, square root of 1 minus p squared. The tan is y over x, so it is the square root of 1 minus p squared all over p. Okay? And then that is all on the part where we have to write these trig ratios in terms of P. All right? First of all, we make sure that the denominator is 1 so that you'll be able to work from your right angle triangle to get the y or the x and so forth. And then from there, you make sure that you relate everything that you've got there to 20. And then you go to your diagram, then you answer your questions. Right, I need some water myself, and I'm sure you also want something to drink. Let's go for break, and then we meet after break. Welcome back, grade 11s. We continue with revising for our paper 2. Continue with the trigonometry, and there's nothing tricky about trigonometry at all. All right, so now the next question, which I know for a fact that you guys are working so hard, hand in hand with me, you can do this question in 1 minute. Let's try it. Just work with your friend as quick as possible. When you're doing maths, you have to be fast so that you can be able to go back and rectify mistakes that you've done, maybe in question 1, 2, and so forth. So this one, let's go for it. 1 minute. Right, guys, let's check if we're doing the correct thing. 180 degrees minus, which quadrant is that? It's the second quadrant. How is the given ratio in the second quadrant? So you see, we're going back to the CAS diagram that all students take coffee, right? In the second quadrant, sine is positive, so we get sine of theta times 90 degrees minus, which quadrant is that? It is the first quadrant. All the trig ratios are positive in the first quadrant. But because of 90, remember guys, your cos changes to sine. So you've got your sine of theta. Divide by, okay? So we've got 360 plus theta. It's the fourth quadrant. How is cos in the fourth quadrant? It is, no, that's a fifth quadrant. It's going back here. That's 360 minus. So here, back onto the first quadrant, cos is positive. So you get cos theta times 180 plus is the third quadrant. How is sine in the third quadrant? It's negative. Then you get negative sine of theta, right? Then they're like, okay, so you've got the sine that divides the sine. And then how it's going to be our sine at the end of the day? It's negative because you've got a plus at the top divided by a negative. So you have a minus. So you've got a minus sine theta over cos theta. All right, so now sine over cos goes back to our quotient identity, right? Sine over cos is 10, so we've got negative 10 theta. So our final answer is negative 10 theta. All right, now guys, coming to your solving of your equations, remember what is very important when you're trying to solve or maybe generalizing, finding the general solution and so forth, is that your trig ratio should be the subject of the formula. So your sine, your cos, your tan. There will be a lot of things next to sine or cos and whatnot, but you work it up until you get sine on its own or tan or cos. In this case, you have it that way. So tan is equals to. Then you find your reference angle, okay? So your reference angle is given by, now in this case, that's your shift tan of 2, right? 68.43. 63. 63.43. 63.43. Okay. Now, this is your reference angle. Then from there, you go to your original problem. Okay? This is tan theta equals to positive 2, right? Now, positive 2, where is tan positive? In two quadrants, the first and the third quadrant. How do you find your angle in the first quadrant? That's 0 degrees plus an angle. In the third quadrant, it's 180 plus an angle, all right? So, you've got your theta equals to 0 degrees plus 63.43 plus your 180 degrees times k. Remember, you have to have your period of tan, or theta is 180 plus 63.43 plus your period, which is 180 times k. All right. Then you simplify. Your theta is 63.43 plus 180 degrees times k, or your theta is, now you have that 180, I've got that answer, plus 180 degrees, that's 243.43. 243.43 degrees plus 180 times k. Now, guys, be reminded, this is just your general solution. Now, they're saying your theta is an element of 0 to 360, all right? So, you now indicate your k is an element of any integer. Then you plug in, you check your integers, -1, -2, 0, 1, 2, and so forth, okay? So, and then we find that theta is, if your k is 0, you get 63.43, right? And then if you put a 1 here, that is 243.43, and so forth. You can check if we have others more than that. If you add 180 here, no, then that is your 63.43 and 243.43 are the only ones that we have there. Okay, now the next one, solve for theta, and your theta has to be from 0 to 360 as well. First of all, you find your key angle. In this case, your sine is a subject, so your key angle will be shift sine of 0.5 is 30. So our key angle is 30 degrees. Then you've got your 20 degrees plus 2 theta. It's equals to, now you look, sine is positive in the first and second. Remember the sign that's here, it's a plus. So positive in the first quadrant, so it's 0 plus 30, so that's 30 plus, remember our period of sine is 360, so that's 360 degrees times k. Or you have your 20 degrees plus 2 theta is, second quadrant is 180 minus 30, that's 150 degrees plus your 360 times k, and your k is an element of any integer. Then you simplify, you get your 2 theta is 30 minus 20, that's 10, plus 360 k. What happens next? You make sure that your theta is a subject of the formula. Then you've got your theta is 5 degrees plus 180 times k. What has happened here? I've divided by 2 throughout. Okay, so now next, making theta the subject, so you've got your 2 theta is 130 degrees plus 360 times k, and then your theta is 65 plus 180 times k. Now, guys, quickly, what you can now do is to plug in the values of k, okay, which is now easier. If k is 1, you'll have your 180 plus 5, okay? If k is 2, you'll have your 180 times 2, which is 360 plus that, so it's above our restriction. So some of the options that we have here, theta is 5 or 185 should be positive, all right? And then here you've got your theta is 65, or you add the 180 plus 65, that's 245, 45. It's still under within our restriction and so forth. And then the rest you can also check, guys, if there's something that we're missing out. But the idea is, okay, how do you get from the general solution to now finding the values of theta? All right. Now, next question. Now, if you are looking at these questions, they were easy type questions where we have to grab all the marks. Okay, there's section A, section B, and then section C. Some of the questions will come in section C. And then, like looking at this one, which is also part of your analytical geometry, that it says x and y, find x and y if P is a midpoint of the line joining Q to R. So you've got, I'm making just an example here, your Q is x and then 5, and then your R is -1, 9, right? Your P is the midpoint, right? P is 3, P is 3 and Y. So what I'm trying to do here is to show you that you can be able to work out your X and Y values if you've drawn a picture. How do I find the midpoint? Midpoint is x1 plus x2 over 2 is to y1 plus y2 over 2. So the x1 in this case is x plus that 1, which is a -1 over 2, is we are given the midpoint that is 3. Then the y1 is 5 plus the 9 over 2 is given, it is y. So now you simplify, so x minus 1 is 6, x is 7, and then 14 over 2 is y, then y is 7. Okay, so you can interpret it that way. Now, here, they're asking us to determine, all right, A, if points A, B, and C are collinear. They keep on bringing some of these words, and you need to go back. What is happening when the points are collinear? So it means that they lie on the same straight line, so they have the same gradient. So in other words, gradient AB is the same as gradient BC and also the same as gradient AC. So gradient AB, gradient BC, and gradient AC. Now, guys, how do you find gradient AB? It's a change in y over change in x. So that would be your minus 3a plus 4 minus your a minus 2, because we've got a minus and then bracket the a plus 2 all over x2, it's minus a minus this a plus 1, okay, is the same as the gradient, maybe your gradient AC, which is your 5a minus 2 all over x2 is your 2a plus 1 minus x1, which is your a, minus 1, which is a plus 1. And then, guys, this, we are going to simplify that and we'll have a on its own. So you've got here your minus 4a plus 2 all over minus 2a plus 1 equals to 5a minus a, that's 4a minus 2 all over 2a minus a is a plus 2. All right. The left-hand side, if you look at the left-hand side, guys, it simplifies to the bracket 2 minus 2a plus 1 all over minus 2a plus 1 equals to 4a minus 2 all over a plus 2. Right? Now, that divides at the minus 2a plus 2, you get a 2 equals to 4a minus 2 all over a plus 2. Then you cross multiply, you get 2a plus 4 is 4a minus 2. Then your 4a minus 2a is 2a equals to 6. Therefore, our a value is 3. So you can just go back and check the steps. So your value of a is 3. Now, determine the equation of line AB in the diagram below. You given y is 3x plus 1 and then line AB here. Guys, just because of time, what you can do is to find, I'm just going to give you a hint, find the inclination here, so the angle of inclination, all right? And then from there, you'll be able to find this angle, which is now, that angle outside will be equal to the 45 plus that angle. Then you have your inclination for this side, and then you say your m is your tan theta, all right? And then once you've got your gradient, then you sub in the point 3 and minus 1. Guys, from me, I would say goodbye for now. Till we meet again. Cheers. Bye.